Hello? Oh, we're on. This is great. Hi, React Toronto. Thanks everybody for coming out on a rainy and windy Thursday. Early spring, it's cold, but we got a really good turnout. This is really exciting. So we have two great speakers lined up for you tonight. Before I introduce the speakers, I want to go over a few logistic things. One, lavatories, washrooms, they're just down that way on the hall on your right-hand side. There's signage on the floor and on the walls if you look carefully. So that's one piece of operating business. If you need to go, it's right over there. Another thing is if the speakers are doing questions and answers, just raise up your hand and we'll run over and get you a mic when the time comes, because we want everybody at home or later for posterity to be able to hear your great questions. And just before we dive into the speakers, thanks everybody for coming out. If you're not aware, this is Rangle's office. We're a digital transformations consultancy. We're about 6 years old, and we help companies move their existing and legacy operations and procedures and processes into the 21st century. And we do that a lot of the time using React, which is why you're all here. So we're going to get started. Our first speaker tonight is Purvi Kanal, and Purvi's going to be talking about single-page applications and the fact that you might not actually need one. And without further ado, I'm going to hand the mic over to Purvi.
Hello. Oh, this works. Cool. Technology usually doesn't just like work the first time I try, so let's see how the screen portion of this goes. Cool. Oh, okay. Yeah, we're all up. So, hi everyone. My name is Purvi, as Michael mentioned. I'm the CTO of Bridge School. We are a federally incorporated not-for-profit, and we teach advanced software development and design skills to women, agender, and non-binary folks in Toronto. And we've been doing that for about 3 years. On the social media, you can usually find me at Purvi Kanal almost everywhere except GitHub. I'm P Kanal on there. So what I want to talk about today has a little bit of a story behind it, and I want to tell you that story before I dive into the tech portion, because I think it like frames a lot of feelings that might be shared with other people. So I had to, for our business, we had to build the Bridge website. So that's the website that you go to when you type in Bridge School Toronto. That's the website we wanted everybody to go to. That's where all of our content lives. That's where all of the information about our programs live. And so a couple of years ago, when we weren't really an organization or anything, we got together on a Saturday with like a couple of us, and we put up 4 HTML pages on an S3 bucket and tied that to the Bridge School.io domain that we bought that day. And that was great. It was like 1 day of work. We got all our information up there. But I feel like you can probably imagine what happened. So like anytime anybody needed to change, I would get a Slack message like, hey, Purvi, can you just like change this content a little bit? I know it's annoying. So the main issue with that was because it was, everything was kind of hosted on S3 and everything was done through Git. You needed somebody who knew Git and could use GitHub to make the most basic content changes to the website, which a lot of the time ended up being me. So every month we'd have sort of like a talk, you know, like, oh yeah, we should probably attach this to the CMS at one point. Every single month without fail it would come up. But just like in most organizations, everything becomes higher priority than your marketing website. And at one point we just kind of got to critical mass of, you know, we really need to be able to change this content, to generate new content, to really like enable our organization to do awesome things. And I knew I wanted to use React, so we decided that we were going to prioritize it. I knew I wanted to use React because I was like, I'd like a component-based structure. I don't like the fact that I'm repeating myself so much. I want this component-based situation. But when I started thinking about it, and I was like, well, So am I just gonna like run create React app, and then I'm gonna have to do like server-side rendering because this thing has to be, you know, optimized for search engines? I was thinking about all of this stuff, and that really got me to thinking about how single-page applications are the norm. And I was like, wait, how do we get here? Like, what has happened? Like, this is what the web is all about. So hands up if you've ever had a GeoCities like website. Yeah. Right? It was so fun. You could like go on there, write some HTML, and then it was on the internet. And so anybody could go and like look at that document that you just created. And that's what HTML was created for. It's a markup language for you to create documents. It actually doesn't have anything to do with programming. So, you know, you're just like, everybody had a website and they could put it out there and express themselves with like all of the clouds that they wanted. But that changed, and I was just thinking about like how we got here. So before you would, you know, in like the old web, for early HTTP servers, it would just respond to a request from a web browser and then respond with an HTML document, and that's kind of like this style, and also the old Bridge website. And it would just correspond to like routes in a file system, because what you're doing is you're just like, hey, bridgeschool.io, point to this computer and show me what's inside the file system. But today's HTTP servers do all sorts of interesting things. They respond with dynamic content in many different formats like HTML, XML, JSON, and they serve both static and dynamic content. So as we got more functionality, we were like, okay, well, it's not enough just to have documents that are served up. We want to be able to do more interactive things. So things like Ruby on Rails was born, where you actually have a whole system where your backend is, you know, generating these templates based on the information that it needs, and then it's spitting it out and sending it to the front end. And then we wanted to do some more interactive stuff, and you're like, you know what, I don't want to use Rails to like make an API call and display like a weather icon. So we're like, all right, let's use some jQuery. And then we somehow jumped from jQuery to like, let's just serve the same index.html file on every route, and let's just let JavaScript deal with it, which is just like the opposite of how the internet was built. So that's interesting. We kind of made technology that enabled better user experience. So like, it was no longer acceptable to have a refresh when you were changing pages, or to refresh to get new data. You wanted fully immersive and dynamic websites. And this kind of was born. That's how web applications were born, and that's like why I have a job. And we wanted faster loading, we wanted progressive web applications, we wanted all of these things, and we made them happen through JavaScript. But that makes things pretty complicated, because we got away from the functionality that the internet was sort of like built on. So we started doing things like server-side rendering. So all of the simple things that we could take for granted when we were using the internet to share files in a simple way kind of went away when we got to the SPA model. So now we've come full circle, and we're actually like rendering the markup that we're dynamically generating on a server. That's not like the first solution, right? That's just like a result of like how we got here. And even our static sites have a ton of dynamic functionality. And so we kind of have this way of thinking that, well, no matter what I'm creating, I'm gonna go right for a single page application. But you really might not need to. Performance also became a really big deal as we started using our mobile devices for everything. DoubleClick by Google actually found that 53% of mobile site visits were abandoned if a page took longer than 3 seconds to load. All of this kind of like led to some JavaScript fatigue that I think a lot of us have heard about. It's been talked about a lot in the community of like, to get a simple app running, you need to understand frameworks, you need to understand how libraries work, how NPM works, module loaders, task runners, bundlers, transpilers, compilers, source maps. It has such a steep learning curve. Like, how did we get from like, I have a web page to all of this? So that's really when I was just like, you know what, there must be a better way, because this is kind of like how I visualize what it sometimes feels like to roll my own React solution for a lot of things. I'm just like, it'll start off good, like maybe I'll crack the eggs okay, and then it's just like kind of a disaster. So I started with the requirements. I was like, okay, I need an easy to use CMS. And by easy to use, I mean like it has to have like rich text editing. It has to have enable all of the people that are creating content for the Bridge website to go in without any oversight and make whatever changes they want. We need a reusable component system with a really easy to use code base. This was something that was really important because we're not working on this 40 hours a week. This is something that we would have volunteers work on, switch in and out of. Might not be worked on for many months, and then all of a sudden might need a ton of work. So it had to be really easy to use and really well documented. Has to be optimized for search engines. It has to load super fast. It's just a content website. It's not doing very much. We have to be able to preview content changes, and we have to be able to share those, because again, we're all volunteers. We're kind of like working asynchronously a lot of the time, so you have to be able to communicate all of the changes that are being made. We need continuous deployments because I don't like deploying stuff. And we needed a Stripe integration for donations. So I was like kind of thinking about this. I was thinking about React. I thought about like, okay, so I'm gonna go in, I'm gonna create React app. And then I thought about React router, and I was like, no, I'm not doing that. So I started doing some research, and I came across the JAMstack. And what the JAMstack is kind of a new way of thinking. Not even actually like completely new. We were already doing a lot of this, but a defined new way of thinking. So it has a JavaScript portion. And what that means is that any dynamic programming that's running during the request response cycle is handled by JavaScript that's entirely running on the client. This could be any front-end framework. It could be a library. It could be vanilla JavaScript. It can be whatever you want. It actually has nothing to do with what specific framework you're using. But it all has to be running client-side. That's just talking to other services, which brings us to the APIs portion. So any server-side process or database action that are abstracted into reusable APIs, and they can be accessed over HTTPS with your JavaScript. So this can be custom built and deployed on serverless frameworks, or even a server if you want to. Or you can leverage third-party services. So for example, if you are running a server-side rendered app, you're not actually JAMstack compliant because you're running JavaScript on the server. If you're running something like Ruby on Rails, you're not JAMstack compliant because you actually have a large part of your backend, which is responsible for your front end. And then the markup piece, which is that templated markup should be pre-built at deploy time. So this means that you're not requesting content from anywhere. All of your content is being pre-built at the time that you're deploying. So this is like, you can use like a site generator if it's content sites, or a build tool like Webpack if it's web apps. And some of the advantages of this is just better performance. You don't have to wait for pages to build on the fly. You can generate them at deploy time. Everything is built. So when it comes to like minimizing time to first byte, nothing beats pre-built files that are served over a CDN. You have more security because you're reducing the surface area with your server-side processes being distributed. And also your front end, the likelihood for cross-site scripting attacks is lower. It's super cheap and much easier to scale because your deployment is basically just like a stack of files. You just put it on a static server, and that can scale as much as you need it to with a CDN. It's also a better developer experience. I don't know if anyone's had the experience here of like trying to get a development environment running, and maybe it takes you like, I've had environments in the past that have taken me like days to set up, and if anything changes, it's a nightmare. So as soon as you have looser coupled services, things get a little bit easier. So the tech stack that we landed on was we were gonna go with Gatsby, which is a framework that's on top of React and Webpack. which gives us the reusable components part. It has everything you need to load really fast. It has all of the SEO optimizations that we need. For the Stripe integration, I just made a really small Lambda function and put it on AWS. And for Netlify, we used it for two things. We used it for the CMS, so the Netlify CMS is super easy to use. It has an awesome, rich text editor, and it's very customizable because it is also itself built on top of React, which means you can do a lot of awesome things. Previewing content changes is live and shareable. And then on the platform side of Netlify, we used it for our deployments and to host our content. So, talking a little bit about Gatsby. So Gatsby, as I mentioned before, is a framework that is built on top of React and Webpack. It allows you to pull data from anywhere, from many sources, from one sources, whatever you like. And so that could be like a headless CMS, it could be a SaaS service, it could be an API, it could be a database. And then it injects all of that information at build time into your bundle using GraphQL. It's really great because it builds your site as static files. So this is kind of the key difference between Gatsby and other single page options, is that it's actually pre-building all of the different pages. So you would never have to pull in something like React Router because you're not actually like doing anything on the routing side. So it's JAMstack compliant. It automatically generates static progressive web apps. So you get code and data splitting right out of the box. I know that I've messed around with Webpack many times to enable doing that myself. And I wouldn't have to if I use Gatsby, so that was another. It also loads only the critical HTML, CSS, and JavaScript that you need at the time, and it pre-fetches resources for other pages, so clicking around your site feels really, really fast. So again, these are a lot of optimizations that I've heard about and a lot that I've implemented myself, probably much more poorly than Gatsby does. So yeah, it pre-builds pages. It can be delivered over CDN really easily. So what that looks like is you have your data sources. So that might be in your file system. So you might have your posts or your pages in your file system. It could be data from a YAML or JSON file. It could be a CMS or calling APIs. All of that gets fed into Gatsby and its power, and that's through your queries. So whatever you're querying with GraphQL is actually built at deploy time. And then it connects to your React components. And then what you could do is you output a static build file that then you can deploy on any static host like Netlify, S3, GitHub Pages, anything basically. So in code, what that looks like is, I had talked a little bit before about how pages work in Gatsby. So anything you have under the pages directory, of course you can specify whatever directory you want, but out of the box, whatever you have under pages directory, any JS file you have under there that you export default from, that is what is going to show up when you navigate to that page. So if I go to the home page of this application, I'll see hello world. If I go to the about page, I'll see about Gatsby, such wow, very React. So that's cool, but that's all 100% hard-coded, and there's no dynamic data being pulled in there, and that's where GraphQL comes in. So there's many options for loading data into your React components. GraphQL is a query language, so if you're familiar with SQL, it works in a really similar way. You use a syntax that allows you to define what data you want to ask for, and it gives it to you. GraphQL was created by Facebook to help product engineers pull the data that they required into their React components. So it was literally built for this reason, and Gatsby kind of uses it in a slightly different way. So it allows components to declare what data they need, and then Gatsby makes that data available when in the browser when it's needed. So it's actually not doing anything at runtime. It's compiling those queries before at build time. Gatsby also has a really rich plugin ecosystem. So Gatsby plugins are just node packages that implement the Gatsby API. There's almost 1,000 plugins to use with Gatsby, and this is really powerful because you have plugins that take care of SEO, responsive images, offline support, file system reading, all of your CSS needs, Stripe, RSS feeds, TypeScript, almost anything you can think of, there is a Gatsby plugin for. And this really does away with the idea that you need to roll your own anything. So if you are building in the Gatsby ecosystem, it's pretty likely that somebody has solved a lot of problems that you're going to encounter yourself, and there's a plugin for that. It's really easy to configure plugins. You would just install the package and then add it to the Gatsby config plugins array. And that's it. That's how you add a Gatsby plugin. It's really awesome. So one of the plugins we used was the plugin for the Netlify CMS, which exists. So features of the Netlify CMS, it's awesome. It's like a web-based web-based UI. It has rich text editing. It's built on top of React, so you can actually build a lot of your own components and things for it. It has drag and drop media uploads along with a lot of other features. It's platform agnostic, so you don't actually have to use Netlify CMS if you're going to deploy on Netlify. You can use whatever you want. Super easy to install, as I mentioned before, especially on Gatsby. All you have to do is install the plugin. And the CMS itself has really good authentication system. You can authenticate using GitHub or GitLab or Bitbucket, JWTs, whatever your team is using. It supports a lot of flexible content types. So it has, I think, like 12 defined content types, anything that you'd expect, like images and text and markdown. But you can actually extend that. So you can create your own previews, your own widgets, your own types of content. It's really, really powerful. It's as customizable as you need it to be and as simple as you need it to be, which is the main reason that I picked it. So the way that you configure the shape of your CMS is you basically have like a YAML config file. And what you do there is you have sort of like a top level category, which is, for example, where I want all of the pages of my website to live. And then under that, I would specify what those pages are. So in this case, I have my home page that lives at source pages index.md. So I mentioned earlier that anything that lives under the pages directory automatically becomes page in Gatsby. And that's actually true for markdown files as well, as long as you have the plugins to support it. So it's really powerful. So what Netlify CMS is actually doing is your content doesn't live anywhere except your GitHub repo, which is really cool. And then the shape of your CMS is actually what you can define. So a couple of the fields that I would want for my homepage is a title and a header image. And within the UI of Netlify CMS, this is what that would look like. I have like a text field where I can change the title. I have somewhere where I can go in and I can upload my image for the header image. And what the workflow looks like is you make a change in the CMS and then you hit save. And it'll open up a PR to your GitHub repo with the changed markdown file. So it'll actually change everything in there. You'll approve the changes. It'll get merged to master, and then master will trigger deploy to production. So that's what allows Gatsby to pre-build all this stuff, is because all of your data is already in your repository. So how do you get that data into your components? And that's using GraphQL queries. There's other ways to do it as well, which we'll talk a little bit about later. But for the most part, you use GraphQL queries to actually get the data. So let's say I have, under a config portion of my CMS, I have the menu navigation stuff. So I'm making this query. You import these methods, GraphQL and the static query component from Gatsby itself, and that allows you to make that query, and at build time, it'll actually run it and inject all of the correct data into here. So a couple of things. So here you're seeing this front matter property. And so what Netlify CMS actually does is, even though it's saving to a markdown file, what it's actually saving is something known as front matter. And you can kind of think of that as like Markdown, but with keys. So because I might have many different pieces of information for my homepage, I want to be able to access them through a key. And front matter allows me to do that. So that's sort of the reason it's saved in this front matter context. And then once I get my query, all I have to do is pass static query a component to render, and it exposes the data that I'm getting back from the query. So on the site page, I have my menu navigation, which is specified here. And then I'm displaying some text, and I have my link to a URL. So I think I mentioned earlier about being able to preview things live, and that's one of the things that Netlify CMS allows you to do. So if I'm filling out my information here, it'll update live on the right-hand side, which is really awesome because as I'm making changes, I can see them updating live. You have to do a little bit of configuration to get that going. So you have this like CMS.js file where you have to register a preview. So you can say like for the home, and what this corresponds to is here where I'm calling this home. So it's saying like for that portion of the CMS, this is the preview I want to see on the right-hand side. You import your template, and it exposes this entry property, which is actually where all your data lives. A little gotcha is that the data is all provided to you in immutable.js. So you have to like go in and use all the immutable.js functions to get the data out of it, which is a little weird, but once you figure that out, it's super easy. And the other awesome feature about Netlify CMS that we absolutely love is the fact that you can create new pages for your website on the fly. So if I set this create flag to true, that means that my team can go in and create a new page. So let's say I have an event coming up. So I could go to bridgeschool.io/react-to 2019, and my team could create that whole page themselves with zero code config. So far we talked about how Netlify CMS allowed us to do a lot of complex work, and it has the markdown type that helps us a lot. But layouts get really complicated really quickly. Even something kind of simple that looks like this, there's a lot going on. So if I look at this page, I have a paragraph, I have a heading, and then I have this list component, but the list component is styled as sort of side by side. And then I have this testimonial component, and so that includes like an image of the person, it has the quote, and it has the attribution. So if I'm thinking about it as like, I could do this all with Markdown, no problem, but it's not gonna look exactly how I want it to look. This list, I was like, okay, well, with the list, I could go with, you know, a pure CSS approach if I wanted to, but it starts to get complicated, especially when you get down into groups like here. You can't just achieve this with pure Markdown. So we were looking into some solutions for that, and MDX lends itself basically perfect to what we wanted to do. So what MDX is it blends Markdown and JSX syntax together. So this allows you to write Markdown documents and inject JSX wherever you want to. You can import JSX components and render them directly in your MDX document. You can decide which component is rendered for each Markdown element. This means that I can actually map UL to a custom React component. Sorry, Michael Bennett. Yes, you can actually map that. It's Markdown based, so it's everything we know, it's everything we love about Markdown. It doesn't interrupt your workflow. MDX also has no runtime. All the compilation occurs during the build stage. So what this looks like is, so for let's take the list component. I created a component, which is how I want it to visually render. And I can actually map anything that's a UL to a list component and then pass it to this MDX component that's imported through the library. And that means that any time that my Markdown generates a UL, it'll actually render this component, which is really awesome. And I can do that for any HTML tag. So taking this a step further, if I want, and so this was something that was just like not possible to render with Markdown. But what I can do is tell MDX to recognize testimonial inside of my markdown if it's passed as a component, and then actually pass it off to that, including the props that it's getting. So I can pass all of these components. And what that looks like in the markdown is, so let's say I have my list here. This will generate a UL, so that'll map to my column list. And then I just actually have like a React component here. And that's what you're seeing here, because it's being recognized through the scope. So this is great, but it also then brings about another problem. So the problem with this is now my content team has to know how to write JSX and what is available to them through that. And that means that I have to document all of the components that are available to them. I have to document how to use them. I have to train them on how to use it, because I'm talking about people who are not developers. And I just decided that, you know, that's just not fair, and I think we can do better. So Netlify CMS actually allows you to register your own editors for your components. So what you can do is ask it to match a pattern, and then generate a GUI editor for that pattern, which is really cool. And then all you have to do is register whatever that is. And so every time, so what you can do is there's like a special widget portion, you hit the plus sign, and it'll actually show you a GUI editor with all of this inside, and what it'll render is this. So some takeaways. What I really loved about going through this whole process is realizing that the most important thing is to build software that enables all of your teams. So not only did this enable people like my program manager, direct quote, but it also enabled our developers. And so Renee, who worked on this with me, we talked about it, and it's like it became like a lot less about like how am I going to meet these requirements, and it became more about like what can I do to enable and delight the teams that are using this. And all of this kind of brought me to this conclusion that, which is not a hot take at all. Like if you go to the React and the Gatsby website, this is like the first thing you'll see is React is a view library. But what I mean by this is that we don't actually use Redux. We don't use React without Redux or other data helpers very often. But we do things like roll our own server-side rendering. We roll our own SEO solutions. We roll our own performance solutions. But it's just like, why are we doing all of that? You know, React never promised to do those things for us because it is just a view library. Gatsby is the framework that you can build on top of React. And it actually allows us to yield out of the static world as well. So I would mostly consider like using Gatsby in almost anything that I do, and then yielding out to the parts that need to have more dynamic functionality. And that's kind of like a big thing that I took away from this whole experience. And something you can think about going forward is, well, figuring out whether what you're building, is it static, is it dynamic, and then making the decisions and retrofitting your tech to your requirements, rather than just like thinking, oh, well, I'm definitely going to build a single page application because that's what we've always done. So that's everything that I've taken away, but I also wanted everybody here to take away something as well. So we actually documented all of the work that we did in a starter that we created. And this starter includes Gatsby plugged into Netlify CMS with examples of how to use a preview and the editor. It has MDX plugged in with a render markdown components and examples of how to use it. It's ready for continuous deployment and per PR previews with Netlify, but you definitely don't have to use Netlify for your deployments. And it has page creation through the CMS, so you can create whatever pages you want. While I was making this slide, I was like, I don't know how I'm going to share this with everybody. I was like, can I have like this mind? Can I just like push it to everybody's mind? But I guess I'll tweet it out or something, or take a picture. But yeah, thanks so much for listening. Does anybody have questions? Yeah. Oh, there's a question here.
Okay, this is intense. I might have missed it. I probably missed it. But where did, so in that GraphQL query,
Yeah.
like what is it querying? Is it like a database or like where and what is that? I probably missed it.
That's a really good question. So it's actually not a database. Actually, so the way it works is, sorry, I'm trying to find the slide here. Right. So what this GraphQL particular query is querying is it's looking for the path config, which is like one of the markdown pages under the pages directory, and then it's querying directly from there. So it's actually able to compile that query at build time. Exactly, that's created by the markdown that's created by the Netlify CMS. Yeah. Any other questions?
Did you evaluate WordPress as an option?
I did. We thought a lot about what we wanted to do, but we ultimately landed on a React solution with Gatsby because of the volunteers that we have on hand and everybody's technical skills as well. Yeah.
That was great. I've built something using similar, but I was also looking at using Contentful, and I didn't know that Netlify did the CMS as well. Is it paid for them? Is that a paid service that they offer?
It's not a paid service.
So it's another free thing that they offer?
Yeah, it's just like...
That's amazing.
They're so amazing. Everything is free. I was also playing around with Contentful before, and it almost, like the Netlify CMS seemed like too good to be true kind of situation. Cool.
And what would be the limitation of Gatsby? Like what you cannot build using it?
So there are some caveats, as there is with a lot of technology. So because it's like a static built thing, some things are harder to do, but you can yield out from Gatsby. So if you needed to do any sort of custom solutions, you can just yield out of it, but it is complex to do that, to set that up for yourself. The other thing is there's a few things it doesn't do super well. Like I don't think the developer tools are super great at the moment. And there's many different ways to basically do the same thing, so it's hard to find what the best practices are. The reason we actually made this starter wasn't just because we wanted to make another starter, it was because the Netlify CMS starter had a lot of boilerplate that was really hard to get rid of itself, so we wanted to make our own that was really easy to get rid of all the boilerplate that you need. Yeah, in terms of the development experience, it's a lot of black box stuff, so you have to, there's not a lot of customization you can do unless you dig in and make your own plugins.
So what does a PR actually look like? Is it like, does it change depending on what kind of content you're producing? Is there any kind of like a global map of all the pages as you were showing, and does like every new page have a PR like that? Yeah, anytime you make any change with the CMS, it opens up a PR. What that PR looks like is it's like a regular PR. It's just a change to the markdown file itself, so it'll show you what's been added, what's been deleted. If you create a new page, it'll just be like, I've added this new page under the pages directory, and then once it's been approved, it'll just get merged into master. So all of your content is always living in your GitHub repo. There's other ways to configure that that are custom, so you don't have to have your content live in your GitHub repo, but that seems to be the easiest way, I think.
Hi. So you said that you no longer are using React Router in the front end. How would you compare the performance of Gatsby preloading routes versus React Router in the front end?
I've found a much better experience with Gatsby personally. I think with, well, maybe this is like a little bit biased because every time I have to set up React Router, I get upset. But yeah, I think there's just, Gatsby does a lot of prefetching behind the scenes that you just can't achieve unless you do a lot of custom work with React Router itself. Also, that's not what React Router was built for. right? It was just sort of built so that you can have pages within your single page application.
Thanks.
Two more.
How long does it take to deploy? Does it scale with how many pages you have, or does it render on top of what's already there?
It's pretty fast at the moment, just because all of the content lives in one place, and it scales pretty well with more pages. Of course, if we have like hundreds of thousands of pages, that would become an issue. Right now with, I think we have like 10 or something like that. Deployments are under a minute.
I just wondered how long it took to put all this together.
Oh, 3 weeks when not working on it 40 hours a week, which was also my favorite part. Like, I'm not a very fast programmer, and this was very easy to get going.
Hello.
Oh, hey.
I'm looking at this slide here, and I just wonder, what's GraphQL being used for? I'm used to using Netlify with Jekyll.
Yeah.
So it's very similar to your presentation today.
Mhm.
And usually when I access front matter, I use liquid templating syntax. So I'm just wondering, is GraphQL doing the same thing here?
It's basically doing the same thing. And there's also different ways you can use GraphQL. So if you actually go to our starter, we're not using GraphQL queries to access our front matter at all, because MDX has this awesome functionality that it loads it onto the page context. The only reason you'd want to use GraphQL is if you need to access content that's on a different page than your component is on currently. So just like with Gatsby, you don't have to use GraphQL. It's just one of the options, but it is beneficial to use it.
Thank you.
No problem.
Thank you very much, Purvi. That was awesome. So we're going to be doing a short break. Again, the bathrooms are just over that way to my right, your left, and we'll meet back here in about 5. Thanks again, Purvi, for talking. That was wonderful. Our next speaker, Meltem Kulic. Meltem's going to be talking to you all about automating component variation rendering. I'm not even going to pretend to understand what that means. I'm just going to walk away slowly and let Meltem tell you all about this cool thing, whatever it is. Thank you.
Is this working? Can everyone hear me? Cool. Thanks, Michael. Sorry, that's my laptop, I guess. Yeah. As Michael mentioned, my name is Meltem. I work here at Rangle as a software developer. I'm also a bridge grad, actually. So Purvi was my instructor about like 2 years ago from now on. So that's like a fun fact. So today I'd like to talk about automating component radiation rendering using Cartesian Component, and how actually this approach helped my team here at Rangle to build a design system for a large e-commerce platform. To start with, I'd like to briefly touch on what a design system is, and I'm curious in the crowd, has anyone ever heard of what design system is, or like how many of you heard of it before? Okay, some people, but still, I guess new. A lot of people new to design systems. I don't know what it was until I worked in this project, in my current project. Has anyone ever worked in a design system project? Maybe a component library project? All right. Design system, I would define it as a systematic approach to product development. And that's actually a definition I kind of borrowed from Varun and Catherine. So they have a blog post and a podcast about design systems if you want to check it out on Rangle podcast. It consists of tools, shared guidelines, principles, and code among your inside your brand across your different products, and it helps the teams to build consistent products more in collaboration rather than in silos. And it's basically a single source of truth for all of your products under a brand. Probably the most popular design system a lot of developers might know is Material Design by Google. Also Airbnb, Shopify, GitHub, IBM, they also have their own design systems. So design system, a typical design system have different parts to it. So it has a design language which includes things like brand colors, typography, spacing, all the global styles that are going to be used across different products, and a design kit which includes assets for designers to use when they're building the wireframes and all the pages and whatnot. And then the component library is where you have all your component code. In the developer's handbox, you visualize and test, and you basically use it when building the component library. The documentation is the user-facing part of the design system. So a typical design system user would go to documentation to grab any components, any kind of styling. You can find there the usage guidelines, do and don'ts. So it's basically where all the design system is being documented. So this was like a quick overview of the design systems. I won't go more detail because it's a whole lot of topic on its own. But you might be wondering how like component variation rendering has to do with design systems. Actually, it is more related to the component library part of the design system. So this can be, this is valid for a component library project as well. So as I previously mentioned, you have all your components as part of your component library. Things like buttons, checkboxes, input fields, all the components you can think of to build your application. And when you are building a component library or a design system, the number of components that you deal with grow very quickly, as well as their the way they look in their different variations and in their different states. So as an example here, for the button component, we have like 12 variation, and it has 3 different teams. Some Some of them has icons, so it can optionally take in an icon, and it can be a small button, and also it can be a small button with an icon. So imagine you have more components and more variations. So it's the way normally this looks in the code, like the first thing that you would think of, you would write down your component once for every different variation, which are like your props. So basically you have, for the theming of the button, we have the primary button, it was the black one, the secondary, and the transactional. And then also we had an optional icon, and then a small button, and also a small button with an icon. And this is for every themed button that we've seen for 3 of them. So this looks pretty manual, right? Sorry, that's really early. Like writing all this component instances by hand looks kind of a lot to me. It's a lot of lines of code, and it's hard to actually maintain. What if I need to like call the secondary variant like tertiary or something? So I have to like change that for every instance. And yeah, it's just, we as developers, we like automating things. We don't want to kind of like go inside like code and like change things one by one. So there must be a way to automate this. So here, a French mathematician named René Descartes comes to our rescue all the way from 16th century. Basically, he developed Cartesian coordinate system, which gave rise to the Cartesian product, and that gave rise to the Cartesian component. So what I just said about Cartesian product, so in the context of math, Cartesian product is a mathematical operation that returns a product of multiple sets. So as an example here, I have A and B as my 2 sets, and A has a dog and a cat, and then B has chicken and milk. And doing the Cartesian product of that would give me all the different combinations of these 2 sets. So it would be dog and chicken, cat and milk, dog and milk, and cat and chicken. So this is actually all we need to know to understand the Cartesian component's magic. So basically Cartesian component uses the same concept to generate and render the component for every possible combination of its properties that are passed in. This way you would get your component displayed in its different variations without having to manually write it once for all of these permutations. So let's see how this actually looks in code. So this basically, the output of this is exactly the same thing as the output of the code snippet that I previously showed. You can see that the lines of code that you need to write is like way less. And in here, the way this works is it takes in the component, which is a button in our case, and then takes in all other props that are part of the component, so the children and other props that are specific to button component. And we would pass these values as arrays, and then the Cartesian component basically does the Cartesian product and renders all the possible combination of all these props that are passed in. And also the Cartesian component, yeah, so this is the way the Cartesian component populates our buttons. Also, one cool thing that as part of my team here, we have introduced the container prop to the Cartesian component. That's a container component that wraps every instance of the component. And the way we use it is we actually show the props and their values that are applied to every instance, so that we can verify if we got our UI actually right. Also, another cool thing about Cartesian component is that when you're manually writing these different combinations of props, there might be combinations that you might not be necessarily thinking about, and maybe it's not your use case, but you still actually need to test them, and you need to know how your component looks in that specific combination, and actually Cartesian component does that for you. So it kind of takes up this burden of like thinking about creating every instance with all of your prop values. So here I've recorded a little GIF to show what if I were to like add a new prop to the component. I want to render my component, and I want to see how that new prop introduced changed the way it looks. And it's basically just adding the prop and passing down the values as arrays, and then Cartesian Component does the magic, and I can see how the buttons, all the variations look in the disabled state. So yeah, we've seen the way the Cartesian Component is used, and this is the kind of the source code of it. So basically, the Cartesian product utility function takes in the props and then returns an array of all the combinations. And then using that, we map over those combinations and then create an instance of the component with these different combination of prop values. Another thing that Cartesian Component was really useful for us in our design system project was testing. So using the similar idea, we could actually get our snapshot, UI snapshot testing done using Cartesian Component instead of manually writing test cases for every variation of the component. And the same goes for the accessibility testing. We used X library for that, and we created a function, Cartesian X function, which leverages the Cartesian Component to does the basic accessibility testing for all of our components. And this is actually really cool because whenever we need to push our code to GitHub, all these tests are they're run automatically, and then we can see if we need to fix any testing, and it makes our developer workflow really seamless. Yeah, so Cartesian Component in my team has made the whole component development workflow very easy. It has improved our developer workflow. Our test team loves it because they use it to test all the components. And also the maintenance overhead that comes with writing everything manually comes away with using Cartesian Component. We absolutely love it. And so this is from one of my teammates, his artwork. Because we love Cartesian Component, we always kind of talk about it and come up with all these cool things. So I've included an open source Cartesian Component. So ours is not open sourced, but it's pretty much similar. The idea is pretty much similar. So if you're curious, you can check it out. Also, one of my colleagues actually shared that with me today. That Storybook has a Cartesian plugin. Apparently, I haven't touched on Storybook, but just quickly, it's a tool that would kind of work in, that would be used by, again, design system or component library developers to document the components. And also a link to the X testing if you are curious about that. And that's all I've got for you. Thank you. There's a question. Yeah.
So with doing it in this manner and you're automating the creation of them, how is that going to work out for exclusions? As an example, you have icons in every one of those things, but often brands say you can only use icons in the larger one, not the medium and the small. Are there exclusions that you can use, or how is that done?
That's a good point. We haven't tried to extend the functionality to actually cover that case. That's more like an edge case. So probably what we would do, we would write Cartesian components separately. So in this case, there was just one Cartesian component to get all the variations. But there are some components that we have maybe 2 Cartesian components, and then we don't pass all the props, but the props that we want to have we want to see their combinations. So that's how we get around that, and also we kind of document it. Sometimes we have that variation in our dev environment, because dev environment is more visible to developers, but then we take a note of that, like in the documentation, we need to mention that like they shouldn't be using icon with that variation. So when we document it that way.
I also maintain a design system, and I was interested in performing exactly this, so thanks for sharing that with me today. I was wondering if you've experimented with visual regression using Cartesian components and how that looks.
Yeah, actually, I forgot to mention that. We haven't, because of some DevOps issues with our project, but we want to do it, but we haven't really used it. But we believe that this might be useful, because instead of just having some UI snapshots, you would have the visual snapshot of the component. But yeah, we haven't actually been able to use it for that.
Can I follow you on Twitter and you can post it when you try?
Oh yeah, absolutely. Yeah, I think, well, it's at trilingualmel. You can find me on Twitter.
Okay.
Yeah. There's a question there.
Assuming you're using it with Storybook, does it work with knobs if there's things like text that you want to allow the designers to type in different lengths and whatnot, or do the properties need to be fixed at the time you're setting them?
Well, we haven't, like our designers haven't really used this so far. It was all developers, so we didn't really cover that use case. Like, I'm not sure how it worked out. And I think, because like our documentation site currently is more like the Storybook, where we document our components, and it has a different, so it's like based on Next.js and Netlify. So it's like a whole different environment, and I'm not really familiar with like how you would do that kind of a thing. But I mean, we can always, like a couple of people here have used Storybook before. I've actually never used Storybook, but we can always like discuss later.
Sorry, maybe I have missed something, but I don't quite understand what's the connection between the Cartesian Storybook and the automation test. Can you like explain
sorry,
more
you
details?
said Cartesian Storybook?
Like you like talk about the automation test first, and then we move to the Storybook and the Cartesian components. Just like I'm just wondering what's the connection between these two.
So Cartesian Storybook Cartesian is just like a link I wanted to provide that I heard, like I've never used it, but apparently it's a plugin on top of Storybook. So for Storybook users, I don't know if you can do testing, or like I didn't really use it, but I'm assuming you can get the different variations of your component. For the testing part, it is in my current project that we use our own Cartesian component implementation to do the testing.
Okay, so do you mean actually when we use a Cartesian component, it helps us to visualize the code that we write, and it helps us to test it?
Exactly.
Okay, got it. Thank you.
No worries.
All right. Well, thanks everybody for coming out. Thank you, Meltem, for a great talk.
Thank you.
So of course, stay tuned for another React.io meetup in the near future. And we'll be around here for Q&A and networking and other things. So thanks again for coming out, and
you.